Good morning, everybody. Welcome to another fun-filled morning of Chem 1105 with your host, me, Dr. White. Oh, do I got a fun morning for you people? Yes. All right, important information announcement, important public service announcement, actually, from me, Dr. White. Remember, if you have not handed in all your labs from the past, tomorrow afternoon approximately is the deadline. Hold on. Dirty glasses. Oh, now I can see. So make sure if you haven't handed in past labs, you email them to me by tomorrow, end of tomorrow. Otherwise, you will get a 0 for each lab you're missing. And I don't want to do that, which is why I extended the amnesty program a whole 1 week. Earlier, either Sunday or Monday, I forgot when, I sent out those of you who have missing labs an email letting you know you have missing labs. So I've done everything I can to reach out and, how should I say, encourage you to hand in your labs. And also on Friday, I will talk more about test number 2, which will be a week from this Friday. In fact, tomorrow, today I'm too busy, I'm going to have to write test number 2 every semester. I write new tests because students get to keep them. You get to keep them as a file. If we were face-to-face, I hand them back and students get to keep them the printed version. All right, let's get to work. All right, we're talking about gases. Did any of you happen to think about the air around you as a gas? And when you're feeling the wind, that's molecules in that gas hitting you very hard. And that's the pressure. Most of the time, you can't feel the pressure on you. Well, anyways, let's get to work. Let me just close something I don't need. There we go. All right. We're talking about Charles' law. Charles' law. I'm a step ahead of myself. Boyle's law. And Boyle's law is P1 equal V1. P1 times V1 equal P2 times V2. Remember, this is for test 3, not test 2. And P and V can be in any units. So the question, first of all, is what's P1, what's V1, and all that other stuff? Well, in case you forgot, let's go through it again. And P1 is the initial pressure. V1 is the initial volume. P2 is the initial, and when I say initial, I got stuck on the word initial. Sorry about that. It happens all the time with Boyle's law and me. Is the final pressure. And I bet you can't guess what V2 is. You're right, that's the final volume. Now, this is only true when the temperature is kept the same. And I won't play a trick where I'll change the temperature on you. No, I don't play tricks. Now, this is Boyle's law. P1 times V1 equals P2 times V2. Well, I promised I wouldn't write. I'll be through in about 2 hours. No, not really. Done. All right, let me decode this. And by the way, the other day I realized I thought everybody was seeing it. Let me check. Yep, you should see it. Everybody see the whiteboard? Thumbs up, people. Help me out. All right, thank you. All right, let's go through this. If the pressure of a balloon is 652 torr and the volume is 2.45 liters, L is liters, that's the volume, then what happens to the volume if the pressure is increased to 1.75 times 10 to the third torr? Well, what are we being asked to find? What happens to the volume? Now, this is after you have an initial volume, so actually that's V2, the final volume. That's what we're trying to find. And let me rewrite this better like I normally do. Now, it says the pressure of the balloon is 652 torr. That's P1, the initial pressure. And the volume where you start out is V1, the initial volume is 2.45 liters. And then they say, what happens to the volume? They say, I say in my problem, if the pressure is increased. Well, that's going to be the new pressure, P2, the final pressure, to 1.75 times 10 to the third torr. And once I've done all this, I don't have to look at this anymore. I've got everything. And if you look at those 4 things, V2, P1, V1, P2, all you're dealing with is pressure and volume. And if we're talking about a balloon, we're talking about the gas, and therefore this should come up in your mind. Boyle's law. P1 times V1 equals P2 times V2. I want everybody take a deep breath. You don't have to close your eyes, but I like to. Let it out. Take a deep, oh, I opened my eyes. Take a deep breath. Let it out. I like the hand gestures. Are you nice and relaxed? That's good. Stay relaxed because we're going to do some algebra. Relax. I'm going to show you how to do it, but we're going to do some algebra. Stay relaxed. Now watch closely. What do we want to solve for? V2. In order to solve for V2, we want it alone. Oh no, P2 is there. When 2 things are multiplied and say you want to get rid of A, how do you do that? You divide by A. A divided by A equals 1. 1 times B would be B. So if I want to get rid of P2, because I'm solving for V2, meaning I want it alone on one side, guess what? I'll divide by P2. However, whatever you do to one side, you have to do to the other side. And P2 divided by P2 is 1. So that's V2 equals P1 times V1 over P2. Now, you don't have to do this, but good habits I don't change. I'm going to rewrite this. V2 equals P1 times V1 over P2. Everybody with me? Remember, when you divide something by itself, it's gone. It becomes the number 1. And when you're solving, you want the variable you're solving, in this case, V2, alone on one side. And now it is. And because I took the time to figure out what P1, V1, and P2 are, it's just plug it in. P1, 652 torr. And V1, 2.45 liters. And P2, which goes right here, is 1.75 times 10 to the third torr. Now, before I pick up my calculator, I'm going to use unit analysis again. Really, of course. And notice I have torr on the top and torr on the bottom. And anything divided by itself cancels out. So this cancels out. What units am I left with on top? And the answer is liters. And guess what? Liters is a unit of volume. So I'm on the right track. And now I can pick up my calculator. First of all, I got to turn it on, clear it. And my calculator gives me this answer. However, remember on test number 2, and this will be on test 3, and I'll also say in test 4 in the final, like test 1, underneath your name, it will say, please use proper significant figures for all calculated answers. And therefore, I'm going to let you figure out what would be the number of significant figures in our answer. I'll give you 6 seconds. Go. I'm looking at my clock. Bonus time. All right, I gave you 11 seconds. Am I nice today or what? When you do multiplication division, you have the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. This is 3 significant figures. This is 3 significant figures. All non-zero numbers are significant. And this is 3 significant figures. Remember my slide rule? Dr. Whiteson is right again, 3 sig figs. So round this off to 3 sig figs. Keep the 9, keep the 1, keep the 2, use the 8 to round off. As 5 or higher, drop that, increase that by 1. And the correct answer is 1.12 times 10 to the minus 1 liters. So when you have a balloon and you increase the pressure, guess what? The volume goes down, way down. Oh, this was fun. Let's do another one. And this might be, like I said, 6, and it might even be 8 points. All right, let me decode this in case you can't read my printing. If you have a cylinder of O2 oxygen gas at 3.445 liters and at 746.2, that's the decimal point right there, 0.2 torr, then what happens to the pressure if the volume is increased to 1.274 times 10 squared liters? All right, we're going to do a winky dink on this one. You remember about winky dink, where you help Dr. White out. If I were winky dink, which I'm not really, but just pretend. And what are you trying to find and what are you given? That's the first thing I ask you to do. And I'll give you 60 seconds now. What are you trying to find and what are you given? Your turn to just figure that out right now. Got 50 seconds left. $30 seconds. Time's up. Put down your pencils and pen, hand in your computers. Oh, that doesn't work. But anyways, let's take a look at this. What are you trying to find? What happens to the pressure? Now that's the final pressure, P2. A cylinder gas has a volume, that's V1, 3.445 liters. And it has a pressure, the initial pressure, P1, of 746.2 torr. And finally, it has what happens to the pressure if the volume is increased to this number. And that's your final volume, V2, which is 1.274 times 10 squared liters. And now if we look at this, we don't have to look at this anymore. Look at this. We see, oh, we're talking about oxygen gas, and that is this pressure and volume. And immediately I know I have to use Boyle's law. Now, one thing you've learned this semester, I've cut down on memorization, way down. And this will be given to you important information, test number 3, and the final 2. That's a long way off, so let's not think about that. P1 times V1 equals P2 times V2. Now, once again, it's that winky dink time. If you haven't looked up winky dink in YouTube, you should, or on Google. And why don't you try first, and then I'll do it. Solve for P2. Remember, anything divided by itself is number 1 and is gone. Give me 10 more seconds. 5, 4, 3, 2, 1. No blast off, but let's do this. What are we trying to solve for? P2. Therefore, we want this alone on one side. Oh no, we've got V2 in the way. How do we get rid of something that's multiplied times something else? You divide by it. Remember, anything divided by itself equals number one, meaning it's gone. But whatever you do to one side, you have to do to the other. And I've done that. Now, V2 divided by V2 is 1. 1 times P2, guess what? It's P2. And this side is P1 times V1 divided by V2. Now, I'm going to do something you don't have to do, but I like to. I'm going to rewrite this P2 equals P1 times V1 over V2. And now, since I took the time up here to figure out what is P1, I'll put it in, 746.2 torr. And then I have V1 is 3.445 liters. And V2 is 1.274 times 10 to the second power liters. Now, before I pick up my calculator, I said I wasn't going to pick it up, so stop. I'm going to check my units using another form of unit analysis. And notice I have liters and liters. Anything divided by itself is number one. Therefore, this cancels out. What units am I left with? Torr, which is pressure. So I can now happily pick up my calculator. Take 746.2 times 3.445 divided by 1.27 E2. And the calculator gives me this number. Are you ready? And I'm going to let you figure out how many significant figures the answer should be. And also, you write it down. And then I'll do it. Go. Time's up. This one has 4 significant figures. This has 4 significant figures. And this has 4 significant figures. And when you're multiplying, dividing, oh, I got out of my rut. Yay. When you're multiplying, dividing, you get the same number of significant figures as your answer as the number that has the lowest significant figures. Well, they're all the same, and that's 4. So we round this off to 4 significant figures. Keep the 2, keep the 0, keep the 4, keep the 2, keep the 4. This is the 5th. I use that to round off. It's 4 or less. I'm going to drop all that. And the correct answer if I get the correct units. And you don't have to put down units on my test, but I always do. And that's how you do it. Oh, let's do one more. All right, I'm going to let you try this all on your own. Figure out what are you being asked to find, what are you given, and then do the problem. Now, an important information, this would be given to you. So I'm going to give you a big hint, but you should have figured out that's what we're doing anyways. And P1 initial volume, V pressure, V1 initial volume, P2 initial final pressure, V2 final volume. And just in case you can't read it, if the pressure of air in a cylinder is 761 torr at 4.15 liter, then what happens to the pressure of the air if the volume is reduced to 1.37 times 10 to the minus 2 liters? Your turn. And while you're doing that, I'm going to look out in the internet and see what's happening out in the world. Well, looks like same old, unfortunately. All right, looks like everybody's done. So I'm going to get going. If you're not, you can always come back and try this on your own and then look at the video or write down what I'm doing now. So question is, what are we being asked to find? What happens to the pressure of the air after you do something? So we're trying to find P2. What are we given? The initial, what happens to the pressure of air in a cylinder if the pressure is so much in a cylinder? So P1 equals 761 torr. And the volume initially is 4.15 liters. And the volume is reduced, meaning the final volume, to 1.37 times 10 to the minus 2 liters. And once we have all this, we don't have to look over here ever again, which makes our life easier. And notice that's this pressure and volume. Therefore, I'm going to use Boyle's law. And I'm solving for pressure, P2. So I want that alone on one side, meaning I got to get rid of volume. How do you get rid of something when you're multiplying times something else? You divide by it. But whatever you do to one side, you have to do to the other. And by the way, I make these same mistakes on a whiteboard in a class. So anything divided by itself is the number one. And 1 times something is that something. So this becomes P2. This is still P1 times V1 over V2. I'm going to do something that you don't have to do, but I will. Good habits I don't change. Rewrite it. Since I took the time to figure out what is P1, I'm going to write it in. And V1 is this. And V2 is this. And before I pick up my calculator, I'm going to say, look, liter divided by liter, cancel out. I'm left with torr, and that's the unit of pressure. So I'm on the right path. Now I'll pick up my calculator, make sure it's on, clear it, which is always a good thing. 761 times 4.15 divided by 1.37 double E. Now, don't forget, use on the keypad down here. Hold on, I'm going to go full screen on you. When you're doing minus, use this minus, not this minus. I'll never be a hand model on TV, but don't look at my nails. Anyways, use this one, and I will. Hit enter. Oh, wow. You should see the number on my screen of my calculator. I'll just write some of it. Actually, there are a couple more. Now, how many significant figures should this be? 3, 3, 3. Oh, he's in his red again. Round this off to 3 significant figures. I'll give you 3 seconds. I'll give you 5. I gave you 10. All right, keep the 2, keep the 3, keep the 0. Use the 5 to round off. Is that 5 or higher? Duh. Yep, it's 5. So I'm going to drop all this, increase this by 1. And that would be 2.31 times 10 to the 5th liters. And that's your answer. Now, one of the things we're getting into now and the few rest of the semester is the juicy stuff, good stuff. And you should ask the question to me or yourself, but you can ask me, because remember, there's no such thing as dumb question. Why am I learning this stuff? Well, the obvious answer is, guess what? You want to get a good grade so you can get your degree. That helps. And later on, if you're trying to get into a program or another school, and they look at your transcript and say, wow, that person got a good degree in chemistry. For some reason, I don't know why, people think chemistry is real hard. It's not. It's fun, but I'm biased. I'm a chemist. And when you go to get a job, if they look at your transcript and say, ooh, look what that person did in chemistry. And a lot of people in the real world think chemistry is super hard. Somebody getting a good grade in chemistry, that's a good thing. But really, why learn this stuff? Why learn Boyle's law? How is that important? Well, let's take a look at this. Oh, before I do that, now in the rest of the semester, I'm going to be doing some artwork. Warning, warning. I have no artistic talent whatsoever. My mother was a very good amateur artist or painter, very good, and none of it rubbed off on me. Nothing, zip. So if you feel like laughing, go right ahead. It's permitted. All right, let's look at this problem we just did. We have air in a cylinder. Let's do a cylinder. This is one of my better art days. And it's got a plunger in it. And we start out at right here. And notice we've reduced the volume. So how do you do that? You move the plunger down to here. And what happened? And I made a mistake here. Oops. If you did something like this on a lab, on a test or a lab, I would never take off. You'll see what happened to the pressure. We're at 761 or 7.61 times 10 squared. And now we're at 2.31 times 10, yes, to the fifth. Boy, did the pressure go up real high. So what, Dr. White? Well, think about this. Where have you seen a cylinder where if you press it, the pressure goes way up in that cylinder? And the answer is when you have a hand pump for your volleyball, beach ball, soccer ball, or your your bicycle tires. How do you pump it up? You're going like this. And what are you doing? You're taking in air at a certain pressure, and then the valve in there, you push and keeps it in there until it's at a certain pressure, much higher than the atmospheric pressure, and then it releases whatever gas is in the cylinder. And that is what we call a hand pump. It pumps in, and guess what? Have you ever been to a gas station, or they make you pay now, even though there's one by my house that's still, two of them are still free, luckily. You know how they have the compressor to fill your car tires with gas? Compressor. It's a cylinder that uses electric motor to move the cylinder plunger back and forth, and has a valve, and that increases the pressure of the gas, air. So that's how you inflate your car tires. So next time you inflate a soccer ball, football, or with someone, or you do it yourself, and you're inflating your car tires, putting air into it, you're using Boyle's law. But you never thought chemistry was there. It is. Is chemistry wonderful or not? All right, let's move on. We've done our Boyle's law practice time. Well, I can do this. And now let's continue. Now, the next law is called Charles' law. And the way you say it in words, and do not write this down. I'm going to tell you why in a second. Charles' law is the volume of a sample of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. So here we're dealing with volume, V, and temperature, T. And in gas laws, the temperature is always measured in Kelvin, not Celsius or Fahrenheit. And Charles' law is this: V1 over T1 equals V2 over T2. V1 initial volume, T1 initial temperature, V2 final volume, T2 final temperature. Now, this is a little more complex algebra to solve for either V2 or T2. And here's when I used to put this on a test. Hint, used to. Students got it always wrong because it's beyond their level for this level of class. So guess what? First of all, let me show you the next slide because it's important. Temperature in gas law is always in Kelvin, and Kelvin is degrees C plus 273. Now, Charles' law will not be on any test or final in this class, and it's even written in a slide, so you know it's got to be true. Because when I ask students to solve for V2 or T2, especially T2, they always get it wrong. I think one test years ago, I put on there, out of 48 students, only one got it right. And the other students were pretty good, but this is challenging math. Now, one thing I will tell you about Charles' law, and there's another way of also figuring it out, which I will teach you, is if you've ever seen those party balloons, and if you're at an apartment, I used to have an apartment with a balcony, and you at the end of the party, you tie it up, you had them tied up on the balcony. So it looked festive when people were coming to see your apartment. And it was winter, and the next morning, you look at the balloons and they're all shriveled. That's because when the temperature goes down, the volume goes down. And that's Charles' law, and it won't be on any test. How we do on time? Woo, we got time. If I can get to the right thing. All right. Now, let's get into an area switches on somewhat. Talking about vapor pressure and boiling point. And this deals with boiling of water. And note, your instructor will include aspects of vapor pressure and boiling points that are not in your text. Most textbooks don't include this. I don't know why they should. All right, there are a couple definitions I want to go through right now. This will never be on a test, but I'm going to be using it, so you should know what I'm talking about. Now, evaporation, what is that? That's the process in which molecules escape from a liquid phase to the gas phase at a temperature where it normally be a liquid. And that's like if you put a little water on a countertop, say in your kitchen, and the temperature in your kitchen is, say, oh, I don't know, 22 degrees C, about 74 F, well below the boiling point of water. If you come back in a couple days, it's gone. And if nobody wiped it up, it would still be gone. Why? Because it evaporates. And evaporation is when the liquid becomes a gas. Now, the rate of evaporation and temperature. The effective temperature, evaporation happens at a quicker rate for hotter temperature liquids than cooler ones. And when something evaporates, it takes energy to do that. And because it takes energy, mainly in the form of heat, when something evaporates, it gets cooler on the surface it evaporates from. Now I have to talk about something personal. In case you haven't wondered, men sweat and women perspire. Same thing, but it sounds nicer. If you ever saw me play tennis, and I haven't in a couple of years because my tennis buddy moved out of the area, and also with age, I just gave up tennis. But in the summer, you'd see me dripping. I'd be sweating. In fact, I gave up on headbands. I used to keep a towel nearby because it would be that bad in the summer, even if we started at like 6:30 in the morning when it was still cool. But why do you sweat, or women perspire, when you're working out or playing tennis or running or whatever? That's because your body is heating up, and that's the way it cools your body. How does it do that? Well, let's say you have some moisture on your skin. If you're a guy, that's sweat. If you're a woman, that's perspiration, and it will evaporate, water becoming a gas. And when that happens, it cools down your skin, and that's your body's way of cooling you down so you don't overheat. Now, why do you do more in the hot, humid weather? Because it's harder for when there's already moisture in the air to evaporate that on your skin. That's why Dr. White hates the summer when it's 90% humidity. Oh, I hate that. Now, one place this is used is cooling towers. If you've ever seen cooling towers like you see on the picture right now, you have fans that pull air through and you have pipes inside, and some of the pipes have water inside. And at the same time, you have water on flowing, dripping over the outside of the pipes. And what happens is that these fans suck the air up in here over those pipes that are wet. The water evaporates and the liquid inside those pipes get cold. And I just noticed I'm out of time. All right, cliffhanger. Today is Wednesday. Don't forget, I have my office hour tonight from 5 to 6:15. If you need help, come on by. Also, now for a cliffhanger, I will tell you the story. I'll tell at the end of the class, or because I'm going to cut it out, how understanding cooling towers saved my life and a bunch of other people's lives. True story. And with that, I'm going to say, gang gesund, goodbye. I'll see you on Friday, unless you come to my office hour.